In this video, we'll see class 9 polynomials chapter. In the previous video, I completed remainder theorem. In this video, we will do factor theorem. Okay, let f of x be a polynomial of degree n greater than 1 and let a be any real number. We have two conditions for that. If f of a is equal to 0, then x minus a is a factor of f of x. Okay, if x minus a, vice versa for that previous condition. If x minus a is a factor of f of x, then f minus a is equal to 0. When will we say that one number is a factor of other? For example, if we take 25, when you are dividing 25 by 5, we will be getting the answer as 5. Okay, so we will say this 5 as the factor of this 25. We will say this 5 as the factor of 25. How we are saying that this 5? How we will say that this 5 is a factor? It is exactly divisible. When you are dividing this 25 by 5, we are getting the quotient, will be getting the quotient as 5 and the remainder as 0. That is exactly divisible. So that is the condition explained here. If f of a is equal to 0, if you take any polynomial and when you substitute a in that polynomial x, then x minus a is a factor of f of x. That is, when you substitute this a in that polynomial and when you are getting the remainder as 0, then x minus a is called the polynomial, is the factor of f of x. Vice versa for that is, if x minus a is a factor, if you are telling that some number is the factor of the given polynomial, then f of x, then f of a is equal to 0. First condition is, if f of a is equal to 0, then you will say that x minus a is the factor. Vice versa, if x minus a is, when you are telling that that is a particular factor for that, definitely you will get the remainder as 0. This is the factor theorem. Now we will be doing few sums based on this factor theorem. So first sum. This is a sum based on this factor theorem. Show that x minus 3 is a factor of the polynomial f of x is equal to x cube plus x squared minus 17x plus 15. Okay, you are asked to show that x minus 3 is a factor of that. So it is given f of x is equal to x cube plus x squared minus 17x plus 15. So here show that, you are asked to show that x minus 3 is a factor. That is, when you substitute x value as 3 in this given polynomial, you have to get 0 as the remainder. So x minus 3 is equal to 0. So x is equal to 3. So you substitute x value as 3. So f of 3 is equal to 3 cube plus 3 squared minus 17 into 3 plus 15. Okay, so this 3 cube is 9 plus 3 squared is, 3 cube is 27. 3 3s are 9, 9 3s are 27. 3 squared is 9 minus 17 into 3 is 51 plus 15. Now we will simplify this. 27 plus 9 is 36. 36 plus 15 minus 51. So 36 plus 15 is 51 minus 51. This is equal to 0. So you have showed that x minus 3 is a factor of this given polynomial by telling that this is equal to 0. Second sum. Find the value of k if k minus 1 is a factor of p of x is equal to kx squared minus 3x plus k. So in this question, it is given that x minus 1 is a factor. Okay, so x minus 1 is equal to 0. So x is equal to 1. So we will be substituting x value as 1 in the given polynomial. So given polynomial is p of x is equal to x squared minus 3x plus k. So here we will substitute, instead of x, we will substitute 1. So k into 1 squared minus 3 into 1 plus k. It is given that p of 1, that is x minus 1 is a factor. So P of 1 is equal to 0. So what is P of 1? We'll simplify this. 1 squared is k will get. 1 squared is 1. So k into 1 is 1. Minus 3 plus k is equal to 0. So here this one is 2k is equal to 3. So k value is equal to 3 by 2. So when you substitute k value as 3 by 2, when you substitute this k value as 3 by 2, you will get that x minus 1 is a factor. We will check that. Okay. So P of 1 is equal to k. We got the value as 3 by 2 into 1 squared minus 3 into 1 plus 3 by 2. So this one will be 3 by 2 minus 3 plus 3 by 2. So 3 by 2, this is 1 3 by 2, this is 2 3 by 2. So you can write it as 2 into 3 by 2 minus 3. So plus 1 minus this 2 will get cancelled, 3 minus 3, 0. So whatever k value you got, we have substituted this in the given polynomial and checked that P of 1, that is x minus 1, is a factor of the given polynomial. Third sum is factorize 2x squared plus x minus 15. So this one is what type of polynomial? This one is a polynomial with second degree. So you'll say this as quadratic polynomial. Since this is a quadratic polynomial, you'll be getting two factors for this. So we'll factorize this using splitting the middle terms method. Okay. So this method already I've learnt in class 8. So 2x squared plus x minus 15. So here you are having a coefficient for x squared. So that has to be multiplied with the constant term. Okay. So when you add any two numbers, you have to get the answer as plus 1. The same number when you multiply, you have to get the answer as minus 30. That is 15 2s are 30. Since negative sign is there, minus 30. So what are the two possible numbers? Here you have plus 1, here you have minus 30. So if you take plus 6 and minus 5. So 6 5s are 30. Different signs you have. So negative sign you will get here. The same plus 6 and minus 5 if you take. Plus 6 and minus 5 if you take. Unlike signs. So this one you will subtract. You will get 6 minus 5 as 1. And the bigger number sign is 1. So what are the two numbers? Plus 6 and minus 5. So instead of this, here I am replacing these two numbers. Okay. So 2x squared plus 6x minus 5x minus 15. Okay. So now I am taking these two numbers together and these two numbers together and finding the factors. So these two if I take, I can take 2x common. So balance will be x plus 3. Okay. So here also I have to get x plus 3 so that I can take that x plus 3 common outside. So when I want x plus 3 here, what number I have to take out? Minus 5. So minus 5 into x is minus 5x. Minus 5 plus 3 is minus 15. So here I will take x plus 3 common, balance outside. The remaining numbers will be 2x minus 5. So these are the two factors for the given question. That is x plus 3 and 2x minus 5. Fourth sum. Using factor's theorem, factorize the given polynomial x cube plus 6x squared plus 11x plus 6. The previous sum, third sum, is a quadratic polynomial. So you got two factors for this. Now this is a cubic polynomial. How this is a cubic polynomial? The highest power is 3. The highest degree is 3. So this is a cubic polynomial. So you will get three factors for this. So for finding these three factors, there are two methods. One is, first you will find the first factor. That is same for both the model. Then for finding the next one, for finding the next two factors, you have long division method and also synthetic division method. So whichever is, I will teach you both the method. Whichever is easier for you, you can follow that. Okay. So for finding the first factor, what is the given polynomial? The given polynomial is having 6 as the constant term. 6 as the constant term. So what are all the factors for that 6? So the factors for 6 are factors of 6. Here it is given plus 6 are, what are the factors? Plus 1 minus 1. Plus or minus 1. Then plus 2 minus 2. Then plus 3 minus 3. These numbers are the factors of this 6. When you divide these numbers, you will get exact remainder. That is, you will get the remainder as 0. So you will say that these are the factors. So for finding the first factor, among this, you will be having 1 as the factor. Okay. So how to check this is, first I am taking x plus 1 is equal to 0. That means x is equal to minus 1. First I will substitute. How I can say this x plus 1 is a factor? I have to get 0 as the remainder. So I will take the polynomial p of x is equal to x cubed plus 6x squared plus 11x plus 6. Now I will substitute p of minus 1. So minus 1 the whole cube plus 6 into minus 1 the whole square plus 11 into minus 1 plus 6. So now I am simplifying. Minus 1. This one is minus 1 the whole square is 1. So this is plus 6. And 11 into minus 1 is minus 11. And then here it is plus 6. So here minus 1 plus 6 is 5 plus 5 minus 11 plus 6. So 5 minus 11 is minus 6 plus 6. This is equal to 0. So like if I am not getting the 0 as the remainder, these many numbers are the factors. So one by one you have to substitute in this given polynomial and check whether you are getting 0. So here the first number when I substituted itself, I am getting 0 as the remainder. So x plus 1 is one factor for the given polynomial. So x plus 1 is one factor for the given polynomial. So 2 more factors I have to find. For finding the 2 more factors only, first I will use long division method. Then I will use synthetic division method. Okay. First, long division method. X plus, since we know that x plus 1 is one factor, I am dividing this given polynomial by x plus 1. So, x cubed plus 6x squared plus 11x plus 6. This long division method already I told you how to do this in my previous video. If you check, you can see the long division method in that. So this one will be x cubed. So x cubed into x squared into x is x cubed plus x squared. So this has to be simplified like this. Then subtraction. This one will get cancelled. We'll get 5x squared. Then bring the next term. So here I have to put plus 5x. So plus 5x into x is 5x squared plus 5x. So again this one has to be subtracted. Here when I subtract this I will get 6x. Plus 6x I will get. Then again that 6 I will bring it down. Then plus 6. Plus 6 into x is 6x. 6 into 1 is 6. Definitely I will get 0 only. Here. Why? Because I told that x plus 1 is a factor. So definitely when you are doing long division method, you will get 0 as the remainder. If you are not getting, somewhere you did mistake in this, you have to cross check that. So now this one is the quadratic polynomial I got when I am dividing the given polynomial by x plus 1. So x squared plus 5x plus 6. So this one as usual by splitting the middle terms method, we can find the remaining 2 factors. So this one is x squared. When I multiply, when I add, I have to get plus 5. When I multiply, I have to get here, since the coefficient is 1, 1 into 6 is 6 only. When I find the product, I have to get 6. So what are the 2 numbers? 3 into 2. 3 plus 2 is 5. 3 2s are 6. Okay. So here 2x plus 3x plus 6. So these 2 terms and these 2 terms I am taking. So x into x plus 2. Here also x plus 2 is there. So plus 3 I will take out. So x plus 2 is common. So one factor is x plus 2. The other factor is x plus 3. So what are the three factors? One is x plus 1. Second one is x plus 2. Third one is x plus 3. So these are the three factors for the given cubic polynomial. Next method is synthetic division method. Okay, compared to that long division method, this is simple only. But understanding part is there. That is very important. Okay, so for doing synthetic division, you put L like this, and whatever coefficients are there for the given cubic polynomial, that alone you will take that and write. For x cube, what is the coefficient? 1. Numerical coefficient you have to take. So this is 1. Then for x square, it is 6. Then for x, it is 11. And the whole number and this the constant, you will write it as it is. Okay. Then you put 0. This is mandatory. The first step is you have to put 0 here. Okay. Then what is the first factor you got? You got x plus 1 as the factor. So you have to substitute x is equal to minus 1. So with minus 1 you are dividing this given coefficients. Okay. So here 1 into 0. Here these two numbers has to be added. Okay. 1 plus 0 is 1. And these two numbers has to be multiplied. Okay. So please keep this in mind. This method is called synthetic division method. First step is you have to take the coefficients of the given cubic polynomial and you have to write, and from what number, what is the first factor you got, that you have to write it outside. So this is constant for all the sums. Then 0. This 0 you have to write. So this is the first thing. Then this is the second one and 0. So these three steps are constant. You have to write whatever number is there, accordingly you will write. First one is coefficient. The next one is what factor you got for that is the first factor. And the third one is this 0. Okay. Then these two numbers has to be added. The numbers that is inside this L has to be added. 1 plus 0 is 1. And the what number you got, that you have to multiply it with that factor. So 1 into minus 1 is minus 1. Okay. Then 6 minus 1. 6 plus minus 1 is 5. Bigger number sign is plus. So 5. Then again 5 into minus 1 is minus 5. Okay. Then 11 plus 11 minus 5 is 6 plus 6. Okay. Then 6 into minus 1 is minus 6. So when you simplify this, that is plus 6 minus 6, definitely you have to get 0. As I told you in the long division, finally you have to get 0 as a remainder. Here definitely you have to get 0 as a remainder. So that you put it separately. Okay. Then these are the remaining numbers you got. How you wrote these coefficients alone here, the same way for a cubic polynomial you will have 4 coefficients. Okay. X cube term, x squared term, x term and the constant term. So same way, when you are dividing a cubic polynomial by a linear polynomial, you will get the answer in quadratic polynomial. Okay. So the answer that you got after dividing this by the linear polynomial is a quadratic polynomial. So the first term will be x squared term. So for the quadratic polynomial, the highest degree is 2. So the first term will be the x squared, coefficient of x squared. So you will write, since 1 is there, you will write it as x squared. Here you have plus sign only. So plus 5x plus 6. This is the quadratic polynomial you got. When you are dividing by long division also, you got the same coefficient. Do you remember? Previously I showed you that long division method. There also the same quadratic polynomial only you got. Here also definitely you will get the same thing only. So instead of doing that long division, you can do the synthetic division also. So after this, by splitting the middle terms, you have to find the answer. That is simple. So x squared plus 2x plus 3x plus 6. So this one is x into x plus 2. Then x plus 2 if you take, balance will be plus 3. So the answer is x plus 2 and x plus 3. So what are all the three factors you got for this cubic polynomial? X plus 1, x plus 2 and x plus 3 are the three factors we got when we factorize the given polynomial x plus 2 and x plus 3. So these are the three factors we got by factorizing. If we factorize this given polynomial, these are the three factors we got. This one we are doing it by factor theorem. Okay, so these are the sums we have in the second exercise, in the fourth exercise. In exercise 2.4 polynomials, we are having only these type of sums. These four type of sums only you have. Other than this, we are having extra sums also, not from the textbook, other sums that I will do it in the next video. Please keep watching.